the chat so that Shubhangi, my other student, or Purnima, if she is able to see, they can answer your question. Okay, thank you. Purnima, you can begin.
Okay, thank you, ma'am. So participants, let's start with transfer learning. As explained in transfer learning, we
Recording
use
in progress.
Knowledge of a domain to transfer that knowledge in a new domain. It makes your training easier, less computation cost as well as time is required to train your model. So most of the time we use ImageNet based weights of ImageNet dataset to train the model. And the transfer learning is basically divided into two parts. One is when all the layers weights are freeze, you are not updating the weights while retraining the model on the new data set. Another is fine tuning, that where weights update process is performed for all the layers. So this is the difference. Whenever you will do transfer learning, the weights will be freeze for all our part of the model, and in fine tuning, the whole architecture or part of the architecture is fine tuned. So let's create a new book. The data set will be same. You can use it from your drive as you have done in yesterday's lab session. The next step is rename your notebook. And after renaming, you have to mount your drive to access the data. Please click on this files menu and then mount your drive. Next is we have to change the current working directory. So I'm going in lab 6, day 6. So that will be my current working directory. All the results will be saved in the day 6 folder. Next is we have to read the data from the directory. The same steps we have to follow. We will use TensorFlow. From TensorFlow, import Keras. Then using Keras dot preprocessing, we will read and preprocess that data. Preprocessing dot image. We have to use image data generator. And the only preprocessing step we are performing is image normalization, that is the parameter named as rescale, where we will divide all the pixel values by 255. We are going to store this image data generator class object in a local variable. Then we will use it to read the data from the directories. First of all, let's read the train data. Let me copy the code so that you can also do the same. I'm copying the code in the chat box. Next is we have to read the training data. So our training data must be there in day 5 folder, or in my case, it is there in here in practice folder. So I will use the path from here. This is the folder, split_data folder you have to use. The path will be different in your case. The same data you have to use. So we will use the object trait data gen dot. Then we will read data from the directory using the function flow from directory. The first parameter will be the path of your train data. The second parameter we have to pass is target size. So when you see these state-of-the-art ILSV-based models, you will find out that most of the models are using input size as 224 cross 224 cross 3 or 299 cross 299 cross 3. So that's why we have started with 224. So the target size will be 224 cross 224. The next parameter is batch size that we will set as 8. And then the final one we can use is class mode. Here we will use class mode is the categorical mode. Other than this, we have to set another parameter, that is shuffle. We will set it as true. So this is our train data. So there are 324 images belonging to 2 classes for training data. I'm pasting the code again in the chat box. Please use the same code. We will wait for some time so that you can also do the same. The only change you have to do is change your path wherever your split_data folder is present. Meanwhile, I'll answer some questions. So one question is that why we are using pytorch and what is the advantage of pytorch over TensorFlow or Keras. So when you find out that how you have to implement neural network or any type of architecture, recently most I think all of the papers are using pytorch for their neural network building. The reason is in pytorch you are free to customize the layers, customize the weights and everything there. You can write by yourself. Same way in the TensorFlow also, you can write the codes. But in Keras, it is high-end API. So the layers of optimizers and other things are already available. You have to just use it from the available library. So the advantage of pytorch first is that you are free to write the code by yourself. The second is that most of the work currently available in the literature are implemented using pytorch. It uses, the main reason is that it uses the CUDA or your tensors of your system very efficiently while processing the data. So can we go ahead? Next is we have to create validation data. So I'm creating valid data. And here I have to change the path as validation data folder and shuffle here. Let it make it as false so that the performance will not affect. So this is our validation data, and then third is test data. Here also the shuffle parameter will be false. So I'm pasting the code in the chat box. These are the simple steps all of you have to follow. I'll wait for a minute so that you can do the same. Our data reading and pre-processing step is done now. So there is another question that what is the data set and how to import the data set. The data set we have shared yesterday in day 5 folder. In the shared ML for CV folder, you have to use that particular data set. And then you have to split the data. You can go through the lab 5. If you have not attended the session, you can go to day 5 lab folder. Here you will find convolution neural network or CNN that you can use to create the data set. So I think now let's know this. Another question is that is there a practice folder in your share? Practice folder is my local folder that I am creating just to demonstrate it. But in ML for CV folder there is day-wise folder available. Inside day-wise folder, lab folders are separately given. So after data reading and pre-processing step, we have to download the model from Keras. In Keras, all the available famous ImageNet models are available. So to access the model, you can go through Keras applications. This Keras app, I will paste the path as well. So this is the page where you will find most of the models available with ImageNet weights. This is exception, VGG, ResNet, Inception, MobileNet, DenseNet, NASNet, and EfficientNet models are available with ImageNet weights. So if you want to use any of the model, you can just click on the model. You will find out this is the way you can access the particular model. And this is the reference in which this publication belongs to which conference. Most of the papers are from CVPR. And you can go through the official documentation of the DenseNet architecture and what are the arguments it is taking while accessing the data. So for today's practice problem, we are going to use VGG16 model with ImageNet weights, and then we will do the transfer learning. Let's access the that VGG16 model from Keras applications page. So keras.applications.vgg16. This is the model. Here you have to pass some parameters. The very first is whether you want the top layer or the last layer in the model. If you are working with ImageNet dataset with all the 1000 classes, then you can make it true. If you are not working with ImageNet dataset, you have to make it as false. That is, it will exclude the last layer, that is the classification or softmax layer. The second parameter is weights. In the second parameter, if you don't want to use any weight, you want to train the VGG16 architecture from scratch, you can write it here, none. So it will not take any weight from ImageNet, but here in the transfer learning, we need weights of ImageNet dataset. The third parameter we will pass is input shape. So the input shape we will use as 224 cross 224 cross 3. So this is it. 2x is the model. Now we will store the model in a local variable. Let me check whether it is correct or not. So yes, it is downloading the data, and you can see from a Google API it is downloading VGG16 weight with no top. That is, it is excluding the last layer. So I'm copying the code in the chat box. Please do the same, and if you are facing any problem, let us know. There is another question. Is data set is data annotation? The data is already annotated and it is shared. It is a practice data set with only some 400 images. So can we go ahead with the training part? There is another question. If I need to give my customized model weights instead of ImageNet weight, how to give? Yesterday we have done, if your model is customized, that is you have created your model from scratch by using con layer, max pooling and other layers, and you have saved the weights in first data set, you have saved the weight. Then you will either load the weights again or use the same session at the end of the notebook, create a new model that we are going to do now. You have to create a new model. Till this part, your step will be same. If you are creating, you are using transfer learning on custom model. Up to this part, you have to load the weights of the existing model using either load weight function or load the entire model. Then after that, you have to add or you have to change the last layer of the model, because on a new data set, there are chances that your number of classes may not be same. So let's go ahead, then we will answer other questions. Next is, this is our base model downloaded from Keras applications. Let's check the architecture of this model. So PGG16 underscore model dot summary. So it is, the input is 224 cross 224 cross 3. Then this is block 1 of PGG. This is another block of PGG. This is block 3 of PGG. This is block 4. And then this is last block, that is block 5 of VGG. Last layer is max pooling 2D. The name of the layer is block 5 underscore pool. And this is the output shape 7 cross 7 cross 512. Next is, up to this part, we have loaded the model from Keras website. You can load the model from your local system also if you have the trained model. Next is, in transfer learning, you have to freeze the weights of the layers. Either you can freeze weights of entire model as freeze, or part of the layers are freeze. So to freeze the weights, what you have to do? PGG16 underscore model.
Anu is asking, instead of using ImageNet weights, can we design weights according to application? Anu, no. When you, according to application, you can design, but like that will not be called transfer learning. Okay.
Ma'am, there is another question. Where is residual block? So in VGG, we don't have residual blocks. So if you want to work with residual block, you have to in place of this VGG16, you have to access ResNet 5010, ResNet 101 or ResNet 121 based on your requirement.
So if there is a question on residual block, if time permits, I will explain what is a residual block.
So this is the way you can make your model or all the layers of your model as non-trainable. Now weights will not update while you train the model again by adding some more layers. So after this pool layer, we will add some more layer. Yesterday, what we have done, we have added one flatten layer to convert this two-dimensional output of this layer into one dimension, and then we passed it into output layer. In today's session, let's use another way of converting the two-dimensional output in 1D vector. So for that, we will use global average pooling layer. So initially the Flatten layer were used to convert 2D dimension into one dimension. Nowadays, people are using global average pooling or global max pooling to convert the two-dimension array into one dimension because it uses less number of trainable parameter while creating the model, which makes your model lighter. So after setting this trainable as false, now we will create a new model on the top of VGG16 structure. So first of all, VGG16 output we have to access. So VGG16 output is equals to this VGG16 model dot layers -1. Why I'm writing layers -1? It has multiple layers. I am accessing the last layer. So last layer is -1. That is this block 5 underscore pool VGG16 underscore model dot layers -1 dot output. So this is the way we can get the output of this VGG16 model. Then we will add more layers in this VGG16 model. And this is a way of creating functional API based model. We are not creating the sequential model. Now we will add one global average pooling layer. So I'm writing gap layer is equal to Keras dot layers global average pooling 2D, which will have input as VGG16 output. So this is the way you have to connect your layers. So this will be the first output of VGG16 last layer. Then the output is connected to the global average pooling layer in this way in functional API model. After this, either you can use multiple dense layer. Here we are using only output layer. So output is equal to Keras dot layers dot dense. We have two classes, so I'm writing two here. The activation function we will use is softmax, and then we will connect the graph by using the previous layer variable. So now you can see the layers are connected. Next is we have to create the model. So VGG16 new model we are creating. Keras dot models. Up to now we have used from models, we have used sequential. Here we will use only model. That is your functional API model. It takes basically two parameters. First is inputs and second one is outputs. So in inputs, you can give multiple inputs if your model is multi-input model, and you can also access multiple outputs from this particular type of model. So inputs is equal to our VGG16 output, or no, VGG16 model dot input. So whatever the input of VGG16, we will, because the input layer is from VGG16 model, so we will access the input layer of VGG16 model dot input, and then outputs will be this variable. Output variable will be the output of the model. So this is the way you can create the functional API model. And now let's check whether it is correct or not by printing the summary. Okay, this is output. I don't know. I have written VGG underscore. So this is output. What is the issue? So now you can see it has taken initial layer, input layer, then block 1 of VGG, 2, 3, 4, 5 blocks of VGG. Then we have added global average pooling. Then this is the layer that is dense layer with 2 neurons. Now here you can see we have total number of parameters as 14 million. But the only trainable parameters are 1026. That is from this dense layer. All other parameters we are not retraining. The weight update process will not perform on VGG16 model. The newly added dense layer will only be trained on in this way. All other parameters are non-trainable. So I'm pasting the code. I request you all to please do the same in your system. When you are done with it, please let us know. Then we will go ahead with the training part. In this way, then on the top of VGG16, we are adding another layer, that is global average pooling 2D layer. And to connect the graph, we will use this variable, the output variable of last layer of VGG16 over here. The output of this global average pooling 2D, we are storing in a local variable. Then we will use this global average pooling layer as an input in the output layer. Here we are creating another layer, that is output layer with 2 neurons, because we have 2 classes in our data set. And activation function we are using in the output layer is softmax. Next is, we are creating the model over here using keras.models.model, that is functional API model, which takes 2 parameters. One is inputs and one is outputs. In inputs, you have to provide the input variable, which is from VGG16 model. We are using VGG16 model dot input. The output variable we have created over here, and this is your model.
So there are a couple of requests here. One is by Neha Rathore. She's saying, kindly explain this first part again. I think you have read this. And yes, how we can connect 2 model outputs, 2 models output.
So, ma'am, there are multiple ways as per my understanding. If there are 2 separate models, you have to create a new model to combine 2 models.
Yes, that's one way of fusing 2 models. Yeah. And Neha, I think you have understood this, Neha Rathore. If you have, please do write to us or to everybody you have understood yes or no, whatever you think. Yes, thank you, Neha.
So let's proceed further for training part. Before training, we have to compile the model with hyperparameters as optimizer. The loss function we will use, the learning rate in the optimizer, and the accuracy in the performance matrix we will use. That is accuracy we are using over here. So let's define the optimizer. From Keras, we will use optimizer. And let's use Adam here. You can use SGD, adult grade, or adult also. And the learning rate we will set as 0.001. And then we will compile the model. The name of the model I have to copy. VGG16 underscore new model. Dot compile. Here, first of all, you have to pass the optimizer. The name of the optimizer is optimizer itself. Next is the loss function. So we will use categorical cross entropy loss. Third parameter, that will be accuracy. We are going to use accuracy as a parameter. So compilation process is done. I'm copying the code. Please do the same. The code is there in the chat box as well as on the screen. So there is another question is that is fusing the model is at score level. Sangeeta Rajesh ma'am, I am not able to understand the question. Can you please elaborate it little bit?
What is the question once again? Will you please take?
It is fusing the model is at score level.
That means last layer. Score level. So Sangeeta is asking at the last level. No, there are various methods. People generally apply like global pooling, or they apply fusing the convolutional neural network outputs and then apply some classification model. This can be SVM, this can be dense layer. There are various methods that have been there in the literature. If you surf, you will find that various papers have used parallel CNN models, and then they fuse at the end of it. Various methods. Fusing is one method. There can be various other methods. I think I've yes, Sangeeta, thank you.
Thank you, ma'am. So next is model training that we will do using fit function VGC16 underscore new model dot fit. The first parameter will be training data that I have to copy. What is the variable name? That is train underscore data, valid data, and test data. So train data, the batch size, the number of epochs, and then validation data. So valid data we will use here, and we will store the result in a variable output. And I'm copying the code in the chat box. Please use the same. There is another question. If I have local machine with GPU NVIDIA RTX 3060 with Tensor Core and CUDA core, do I need to use any parameter to use how in kilowatts? So you want to know how you can use the codes and use the capabilities of CUDA in your local system. So as explained in the day one session, first of all, you have to install CUDA application in your system from NVIDIA website. Maybe CUDA 11.4 or 5 you have to install. Then in the same version of CUDNN you have to use and copy paste some 4 to 5 files from CUDNN to CUDA installed folder. And then you have to install, if you are working with TensorFlow, you have to install TensorFlow GPU package, either using conda install or pip install. And at the end, if you are working with pytorch, you have to install pytorch and torch and torch vision in your system. That's all to access your GPU. Nothing else is required if you are working with transfer learning in your local system. So if it is taking a little bit of time, as I have, if I will change my runtime to GPU, it will tell me that I am exceeded the limit, so I cannot change it because of the restrictions of Google. So till it is running the epochs, let's write the code for plotting the graph. The same code we have done using matplotlib. So import matplotlib.pyplot splt, and using plt we will plot the data. First of all, for accuracy, we will access it from output.history. Here we have the variable as accuracy. Similar way, we will access validation accuracy. The same way we will access loss and validation loss. And then we will plot it. Accuracy, validation accuracy. In plt.title, we will make it as accuracy graph plt.x label. So in x label, we will have epochs. In the y label, we will have accuracy, and then we will show the output plt.show. In the same manner, we will run it for loss, it is running the code. Maybe it will take some 3 more minutes. It is done.
Okay.
See that the accuracy is not improving. In this case, we have to change the hyperparameters. But I'm currently not changing it. Let us first check the performance, because otherwise it will take again 5 to 10 minutes to train the model. we have to either change the learning rate and the optimizer also we can change. Then there are chances that the model will improve the performance. And other than this, the data set is very small. So that's why the performance is not up to the mark. So as you can see, the performance is not improving, but the loss is decreasing. In case of accuracy, it is not improving, but loss is decreasing. If you will train for maybe some more epochs, 10 or 20 epochs, then maybe accuracy will increase and loss will decrease, and you will get a straight line. Due to unavailability of GPU, we cannot set it as GPU. We cannot change it to GPU processing. Otherwise, the process can be more fast. I think same way you can also not run it with GPU. So if you are working with GPU, I request you all to please stop your GPU processing after this example, because in the next lab we will need the GPU for YOLO practice. If you will use the GPU now, then maybe in the next lab you will not have GPU capabilities. So please, after running this example, stop your GPU. Next is to evaluate the performance of your model on test dataset. That also we have done. That is using evaluate function. So the model is VGG16 new model. Dot evaluate. And here we have to pass the test data. So there are two questions. I'll answer them after this example. So Shivam sir, you have done it correctly. Your screenshot is correct. So now you can see the loss we are getting is 0.71 and accuracy is 50% on this test data set. Please train your model for some more epochs and then it will reach up to maybe 90%. Next is what we have to explain is activation maps or the feature maps of hidden layers, as somebody was asking in yesterday's lab. So the package we are going to use is...
One more thing, have you explained, I'm sorry if I have missed that,
Yes, sir.
that if suppose you have to do 4 classification into 4 categories, have
Yes,
you
ma'am.
repeated that part? Have you
Yes, ma'am. Maybe at that time only I got disconnected. I was explaining and I don't know when I...
Have you repeated that?
Yes, ma'am. And not
Okay,
now.
fine.
I'll repeat. Thank you.
Yeah. One thing is that...
Ma'am, actually,
Yeah.
Shubhangi ma'am has already answered, so I'll re-answer.
Okay, fine. No
So the
problem.
only change is that you have to change the number of neurons here. If you have 4 classes, you have to write 4 here. No
That's
other.
all. That's very simple. And
Yes.
you were saying something? Yeah.
Ma'am, the activation maps we have to...
Activation maps. Yeah. So how to visualize the output of CNN? So that is what is. Somebody was asking how to visualize. I don't know if that fellow, the person who was asking is present today or not, but you can definitely show us.
Okay. Thank you. So the library we are going to use is Keras. There are some more libraries available. You can use them, or you can write your own code to calculate the activation map or print the activation map of the hidden layers. So the library we are going to install is pip install caret. So it will give us feature maps of hidden layers. Then from caret we are going to import get activations. So you can go through the documentation of this caret package. Then you will know some other capabilities of Rect as well. Using this get activation function, get activations, the first parameter is the model name in which you want to get the feature maps. Next is the image on which you want the feature map. So let's read a new image. Import cv2 cv2.imread. Here we have to pass the path. I'm copying the path of one image, which is a smoky image. Then I will convert it into RGB color space. PGR to RGB. Then we have to resize the image. cv2.resize image in 224 cross 2. Next is normalization of image. So image divided by 255. All the pixel values will be divided by 255. Then let me print the image. Right, I am show over here as this is a image. So this is the image we are going to use. Here we have to pass the image. But when you check the shape of this image, it will be 224 cross 224 cross 3. So before passing it to the model, we have to reshape it into in the form of batches as well. So 1 cross 224 cross 224 cross 3. The third parameter is we have to pass the layer name for which you want to calculate the feature map. If you will not pass anything here, all the layers features will be printed, but it will take a lot of time as well as your system can hang because of printing lots of images. It will overload the RAM. So let's write a single layer name, layers, layer name. We will use this block 5 con 3 maybe, or this block 5 pool we will print. Then we will pass another parameter as auto compile. It will compile our model. It is not compiled. And we will store the data in a variable. So these are the activations of our block 5 underscore pool layer. Now we will print these activations. So we have to import caret, and then using caret, we will display activations. Here you have to pass the activations. So activations are there in activation variable. Then what we have to pass is the maybe every parameter is set. So let's do one thing. Let's run till this part. It will take some time and it will plot all the feature maps of block 5_pool layer. So these are the feature maps of all the layers. Sorry, the layer block 5_pool. These are the filters. So total 512 features are there, each of size 7×7. So I'm copying the code in the chat box. This is to read the image. This is to get the activations. And this is to print the activations or feature maps. Is there any issue in this part? Please run it in your system, check the results. You can change the layer name from here. If you want to visualize, maybe block 1. If I am not
So
right.
Purnima, you have demonstrated well. I think you can go ahead because they may take some time in running on their systems. So they can do it later, right? So important is that you start the pytorch because we don't have time now. It's 7:02 already.
Yes, ma'am.
Yeah. They can later run this and see how this can be visualized. These are all activation maps.
So now we are creating a new notebook. We will answer your question, sir. There is a question related to confusion matrix. We will answer your question at the end, but you can use SQL on confusion matrix if you want to plot it. Plot your data as in the form of confusion matrix. So let's first of all do it with pytorch, and then after completing this, we will answer this. So CNN with pytorch. The data set will be same. Only the syntax will change. Please create a new notebook. Don't change the runtime as GPU. We will use CPU only. Then change your current working directory by mounting your drive to the notebook. I've changed my current working directory. The next step is data reading and pre-processing. pytorch. It is renamed in another way. So first of all, we have to import in Keras we had image data generator. Here the step is split in two parts. So for, to load the data, you have to write multiple parts. In the form of image data generator, we have transforms here. So let's first of all import the transform. So from torch vision, we are going to import transforms and then using this transform we will write the code for image normalization. And here you can also write the code for like image resizing. So using this transforms object, you have to call compose function. In this compose function, here please check here in the brackets you have to pass the parameters. The very first parameter we will use is image resizing, so that we can resize all the images in 224 cross 224. So from transforms, this transforms, we will use resize function, and here also we'll inside another brackets we will pass 224 cross 224. This is our first parameter. Then second parameter we have to pass is to convert the image in the form of tensor. So by default, your data will be read from using Pillow or PIL package. So we have to convert that data in the form of from PIL to tensor. So transforms dot to tensor. Next is image normalization. So that we have done in Keras using rescale variable, rescale parameter inside image data generator. Here we have normalized function. So transforms dot normalize. In this function, you have to pass two other functions. The first one is mean, the two other more parameters. The first parameter is mean of your image channels. So we are using 0.5, 0.5, 0.5 for all the three channels. And the second parameter is standard deviation you have to pass. That will again 0.5 we are using, 0.5 and 0.5. So this is the transform we are going to create. Let's store it in a local variable. So here we have used the transform and then resize the image, convert the image in the form of tensor, and then normalize the image in between 0 to 1. I'm copying the code in the chat box. So you can write multiple transforms for your like. This is we are using for both all training, testing and validation data. But if you want to write a separate code for training, validation and test data, that also you can do. In training part, you can write the data augmentation parameters also. Next is reading the data from the directory. So in case of Keras, we had flow from directory. Here we have the function as image folder. So for that, we have to import the package from the torch vision. So either let's import the complete torch vision. First of all, we will read the train data. From torch vision, we are going to use data sets. And in this data set, there is another class, that is image folder, that will help us to read the data from folders. The first parameter here we have to pass is root, that is your directory where your training files are present. So in my case, I think it is here only. Let me run ls, so it will be here, split data, so it is here only. In your case, there are chances that it will be somewhere else. So it split underscore data slash train is the folder where train images are present. Next is we have to pass the transform. So our transform is this data transform. This is for training data. What is the issue? I have executed this. Okay, maybe I have not executed the cell. So this is the code. Read the training data. Next is we will use the same code to read validation data and test data. I'm copying the code for validation and test data as well.
Like copy paste नहीं कर सकते ना?
Yes, ma'am, they cannot copy paste, ma'am. This is just so that you will not have any typo, ma'am. Most of the time, while typing, there is some typo error.
Sure, yeah.
Query till this part, please let us know.
How come in your place it is showing 30 degrees and in my place 25 degrees?
I don't know. We have to create the loader, data loaders the same way we have done, which will have the batch size and the shuffle options in your data. Read the data from in the form of batches. So this is the third step in PyTorch. In Keras, we had only two steps. One is the generator part and one is the flow from directory part. Here we have first of all defined the data transform. Then we have passed the path of the directory from where data will be read, and then the transform on the data. The third part is the loading of data in the form of batches. So we have to import torch here. Till now we have used torch vision. Now we will import torch package. In torch, there is one option, utils. In utils, we have data, and inside data, data loader option is there. So in data loader, you have to pass the parameter. The first is the data which you want to read and process. So this is your train data you have to pass. Then the batch size. So we will read in the size of 8. Then shuffle value. Yes, we will shuffle the data, and the another option we have to pass is into memory. So it will store the data in our memory. So pin memory should be true while accessing the data. So this will be our train loader. Let's run it. Okay, it is correct. I'm copying the code. I'll answer the questions. In the same way, we will read the validation data and in the form of batches and test data. Here, let's make it as false. So there is a question that is the data transform is same as data augmentation. Here, your data transform, this, if you're talking about this transform, so it is same as image data generator in pre-processing step. It contains all the pre-processing step. Resize, normalization, data augmentation is also the part of this transform. So data reading and pre-processing part is done till now. Next is we have to build the model and train it. So it will take a lot of time for creating the model and training it in pytorch because you have to write the entire code. So let's first of all create the model. So for creating the model, you have to create the class in Python. As there is no other way. You have to work with classes if you are creating a custom model in pytorch. So let's create CNN model. Here, you have to pass the main module of the torch where neural networks are present. So torch.nn module. And then two functions are present inside the class. The first one is the initialization function. And then the second is forward pass function. So in initialization function, you have to pass you have to create the variables. In the forward pass, you have to create the structure of the model in the way your model will be working. So let's create the first in layers initialization step. So define init. We'll use a local variable of the class that is cell. This will work as the object of this particular class. Then to initialize this variable, we will call the super function. Here we have to pass the class name and the object name. And then call the initialize function. Next is we have to create the variables which we are going to use in the forward pass. We will create a small model with two convolution layers. And then we will flatten and then pass it to the next, that is output layer. So self.conv1, we are creating a variable that will access torch.nn dot conv2d. So conv2d is defined inside nn. In case of pytorch, the difference while creating the layers is that the first thing is in Keras, you have to tell the number of filters, then the filter size, then stride, padding, like that you have to tell. But here when you see the suggestion it is giving, you have to first tell the input channel. In the first layer, what will be the depth of your input. That is the number of channels in your input data. The second parameter is output channel. The number of filters you want in your output of the convolution layer. That is the number of filters. Next is the size of kernel, whether you want 1 cross 1, 2 cross 3 cross or 5 cross 5. So you have, accordingly you have to write the kernel size. Next is stride, then padding, dilation if you are using, biases and padding mode you want. So this is the way. So here, while writing the convolution layer, please take care of this part. First of all, we have to write input channel. So when you are talking about the input data, we have 224 cross 224 cross 3. So 3 is the depth, so input channel will be 3. Now, if you want that your output will have 16 feature maps or 16 channels, so I'll write 16 here. If you want 32, you have to write 32 over there. The third parameter is the filter size. So let's use 3 cross 3 filter. I'm writing 3 here. Then we have stride, padding. So I'm excluding other parameters. Stride is by default 1, so let it be same. And padding we are not going to use currently. Here there is a typo. Next is create another variable. That is our next layer. Here the input will be the number of channels in your last layer. That is 16. As you can see, output of first layer was 16. So here the input channel will be 16. Next is how many feature maps you want in this output of this particular layer. So here you have to write 32 if you are going to use 32. If you want 16, you can write 16 again. So like that you can do. Next is other layers you have to define. So let's define the fully connected layers. So we are going to use a dense layer. That is the flatten layer will when you flatten the result of the second convolution layer. So in Keras we have dense, here we have linear. So from torch.nn we have linear function available, which is same as dense in the Keras. It will also take input features and output features. But be careful by writing input feature over here. So you have to either calculate the output shape. What will be the output shape of this convolution layer? That will be the input of this layer. So currently what we are going to do, we are creating convolution layer, one convolution layer, then max spool, then convolution layer. Convolution layer, we are using 2 convolution layer, then max spooling. So when you calculate the output, it will be something 110 cross 110 cross 32. So I'm just multiplying those. And in pytorch, the depth is first. So that's why I'm writing 32 first and then 110 cross 110. It reads your data in reverse order. Depth cross height cross width. So this will be the input of your dense layer, or you can say linear layer, and output you can write how many number of neurons you want. So let's use 16 neurons here. Creating another function, that is this forward function, which will have 2 parameters. One is self and one is your input to the model. So input to the model is X we are using. You can write image or anything. The first layer is self.conv1 we are creating, that is this, which has 16 filters in it, where we are passing input, or you can say image here. The name of the input is X. we are storing it in a local variable again. You can rename it. I'm using the same name, X, and then we are passing it into another, what we can say, another layer that will have the activation function, that is ReLU. So X is torch.nn.functional dot, we have to write here ReLU, and here you have to pass this input. So this we are writing here X. So we are out. First convolution layer will feed into ReLU activation function. Then again we will add another convolution layer. So X is self dot con2. It will have again this as input. Again we will pass it in a ReLU activation. Then let's add one max pooling layer over here. So X is torch.nn.functional. In place of ReLU, we will use max pool 2D. And pooling size we are setting as 2. And then we will flatten the output of this max pooling layer over here. We can add more layers, but it will take some more time because we have to write a training function. So we will modify the model if time permits. We will, at the end, we will modify the model. So let's add the flatten layer over here. So torch.flatten. So this is not a layer. Flatten is a function to convert or reshape your data into one-dimensional vector. So we are using torch.flatten. It takes your input data, that is X, and the dimension in which you want to convert the data. So X, and we want it in one dimension.
So, Purnima,
yes,
is there need of backward function? The question,
ma'am, I have not answered that. So the backward function is already there. We will use it while training the model.
Yeah.
So we have flattened the result into one-dimensional vector over here using this flatten function. Next is we'll add one more layer. That is this linear layer we have created. X is self dot fully connected one. That will have input as X. Again, we will pass the output of this layer into ReLU activation function. So now add one more fully connected layer. Self dot fully connected to, that will be the output of the model. It will have input as X, that is this X. Next is we will pass the output of this layer to softmax. So output will be in the torch. The softmax function is already there. So torch.nn.functional dot, the softmax function name is log softmax over here, and here you have to pass the input, that will be X, and then the dimension will pass as 1. So based on the dimension 1, it will calculate the softmax of your output. and then we will return the output. So let me run it and I'll explain it again. First, let us check whether there is any issue or not in the complete code. Next part, what we have to do, we have to pass the data to the GPU. If you want to run the code in GPU, currently that we are not using. If you are using the GPU, then you have to pass the data, complete model as well as the data from CPU memory to GPU memory. So for that, first of all, you have to check on which device currently your data, your code is running. So for that, you can run torch dot CUDA dot is available devices. If CUDA is available, then we will make the device as CUDA. If CUDA available, then your device will be set as CUDA. If CUDA is not available, then your device value will be CPU. So let's check the device. So currently we are working with CPU. If you will change the runtime to GPU, here you will see CUDA will be written over here. Now we have to call the model and then we have to pass the model to the memory if you are working with GPU or CPU. So CNN_model dot to function we will use to pass the model to CPU. So to device, and then this we are storing in a local variable model. Or let's make it as CNN model. And now we will print the model. So this is the structure of the model. Next is model compilation and passing the learning rate, optimizer, loss function. So for that, first of all, you have to call the optimizer. So in torch, optim is there. Torch.optim. We will access atom optimizer from optim. Here the first parameter it will take is the parameters. So first of all, we have to get the parameters of this CNN model. So you can use this CNN model dot parameters. So it has all the trainable parameters, all the parameters of your model that you have to pass in the optimizer. And the second parameter is learning rate. So learning rate we will set as 0.001 and this will be our optimizer. Next is the loss function. So torch.nn we will use in torch.nn there are multiple functions available. We will use categorical cross entropy loss from that particular library. So cross entropy loss is there and this will work as our weight update criteria. Okay, I have to write LR here. There are slight changes in Keras and pytorch. So in Keras you have to pass learning rate nowadays and in pytorch you have to pass LR. So these optimizer and loss function we will use while training, testing and validation and testing the model. So the training, testing, and validation process is totally different from the Keras part. There is a question, do we have option of using GA as a function in optimizer? Sir, what is GA here? If you are telling global average cooling or global max cooling layers like that, so that is available in the pytorch. Next is we have to write the function for training, validation, and testing. So first of all, we will write the function for training. Define train. Here you have to pass the model, data, the optimizer, and then the criterion or loss function. Then you have to set your model, whether you want to train the model or you want to test the model. If you are training the model, you have to write model.train. Then only your weight update process will perform. Now we will create some local variables that will store the your partial result while training. So we'll use train loss. Currently we'll set it as 0.0. And then we are using another variable that will have accuracy in it. And we are using another parameter, that is the count variable. Now, to access the data from loader or train loader, we are going to use another package that is TQDM, TAGDUMs generally we say. That will access, that will give you your data from this train loader. So, using TQDM, if you are working on local machine, you have to install TQDM, pip install TQDM or TAGDUM. So it will take two parameters. One is your data in the enumerate form. In enumerate form, your data as well as index of the data will provided to you. So here we have to provide the data, that is this data, train loader we are providing. Then you have to provide the total data in your train data. So that will be the length of your train loader. And then we run a loop over it. So for index comma data in TQDM of enumerated train loader and length of the train loader. Now we will increase the counter. Next is we will access the data from this data variable. In this data variable, two datas are there. One is input image and one is label. So to access the data, one is image is there and one is label. So this is the way we will access image and label from the data. Then as we have coded the, we have copied the model from one device to another device. In this case, it is CPU only. In the same manner, you have to copy the data also in maybe in your GPU device. So for that, you have to write image is image dot to, and here you have to write the device. Device we have already defined, that is CPU, or you can directly write here CPU or CUDA, but we have created a variable that we are going to use all over the code. Next is we will copy the label as well in the device. After this, the data is with you. Next is your training part. So first of all, you have to make all the gradient 0 while training the data. That you can do with the help of this optimizer dot 0 grid, so it will make the gradient 0 initially. Then you have to call the forward pass after making the, just imagine the workflow of the neural network. Initially all the gradients are 0, then your data will pass to the model for forward pass, then the loss is calculated, after that backpropagation is performed. So this is the way PyTorch code is written. So initially we have made all the gradient as 0. Next is we have to pass the data to the model. So to pass the data to the model, you have to write model. Inside it, pass your input data, that is the image you have to pass, because on the images you have to calculate the output. This will give you one output or label. Then using this output, predicted output, you have to calculate the difference between the predicted output and then the actual output. That will be your loss. So loss is there in this variable. Loss is defined, this criterion. So you have to use this criterion where you have to pass the actual output and the predicted output. I'm passing the predicted one and then the actual one as parameter. So it will calculate the loss of actual and predicted output. Then you have to add the loss, whatever loss is there in this in-loss variable, so that it will change the loss value. So loss is there, loss dot, using this item function you can access the data of loss variable. Next is to calculate the accuracy, you have to write the code here. You cannot directly use the accuracy matrix like Keras, you have to write the code. So here in this output, you will have the labels, the predicted labels. So you have to get the index of maximum. In softmax, you have the probabilities, you have to get the highest probability of the data from this output variable. So in torch, in Keras we have used numpy, np.argmax. Here we will use torch. So torch.max, max function is there in torch. There you have to provide the output value. So output.data will provide you the complete output. And then after that you have to provide the other is the output, how much, like what is the output you want from the value. So we want the maximum as 1. It will give you 2 values, so we will mainly focus on the prediction. So we are going to use using only prediction. This torch.max will give you 2 different results. Then we will improve the or update the accuracy using this predict variable. So train correct is train correct plus we have the prediction in this. We will compare the prediction with the actual label. If the prediction and label are correct or same, then it will add 1 in this train correct variable. So this is for accuracy calculation. The next part is backward propagation. We have done the zero gradient part, passing the data to the model for calculation of the output. Then we have calculated the loss. In the next part, what we have to do, we have to backpropagate the loss. So for backpropagation, you have to pass this loss And the function, somebody was asking how the back propagation will be performed. So back propagate directly, you can just call back propagate or backward function, and then the loss will be back propagated to your entire model. So I think it's little difficult to maybe understand the complete code at once. So anyone having any doubt, or we can proceed further? Maybe I'm in a little hurry, so many of you are not able to get the things. Or if you allow, we can proceed further. A little bit of code is only left. When the code will be completed, I'll paste it. So the YouTube links are already there in the shared folder. The Python notebook is already shared with you all in the lab 5 folder maybe, because it is from CNN part. So we have uploaded it in lab 5. So after this back propagation, your process is completed. Now only 2 more steps I have to write. One is weight update process with the help of this optimizer. So optimizer dot step I'll call using this step function. Optimizer will update the weight. So this is all inside the for loop. Now we have to return the loss value and the accuracy back to the when you call this training model. So we will return it from here. Before that, let's create 2 more variables that will have the epoch wise loss and accuracy. So we have the loss here in this train loss, and we will divide it with count that have the count of all the epochs. In the same way, we have to use this train underscore correct for accuracy. So epoch accuracy variable we are creating. So it has train correct divided by length of your train loader dataset. The count of the train loader will be, you have to divide, you know the accuracy formula. And then we want it in the form of percentage, so I'm just multiplying 100 over here. And then we will return it. We will return epoch wise loss and epoch wise accuracy. I'll paste the code when I'm done with the let me check is the code is correct. In the same way, we have to write the validation or test code. So I'm writing this validation code. So we need model. Here either valid loader or test loader we can write. Optimizer is not needed in validation because there is no weight update process required in validation or test step. Here we have to change the model status from train to eval to evaluate the model. Then again, in place of train loss, I'll create validation loss. Train accuracy, I'll create validation accuracy or validation correct. Counter we will use. Earlier, we have just executed the for loop, but in this case, as we don't want the model to update the gradient, so we have to set the gradient as false. So So for that, we are using with torch dot no gradient and then inside it we will use this entire code. There are slight changes, some changes will be here inside this code that we will do, but this for loop will be inside no gradient option. So here we have to pass valid data or test data. This is just a parameter, length of valid loader. Counter we will increase, then we will access the data. Data is here, then we will pass the data to the device. No need to, we are not going to use the optimizer, so just removing this line. We have to pass the data to the model, then we have to calculate loss, and then we have to change the loss value. So in place of train loss, we are going to use validation underscore loss. Then in the same manner, we have to calculate the validation accuracy. Loss dot backward will also not be there, and optimizer step will also not be there inside the loop. After this, with definition, what we have to do, we have to get the entire loss or epoch-wise loss, you can say, for validation data. In case of test data, there will not be any such epoch. So for that, you have to divide the validation loss by the counter, and in the same way, you have to divide the validation accuracy with the total number of data in the train loader. So this is for writing the test and validation, training and validation or testing function. Next is calling the functions. So earlier we have used tqdm. So first of all, let's import the tqdm package. So from tqdm or tubdum.auto, we are going to use tubdum or tqdm. Next is, somebody was asking in yesterday's session that how to calculate the response time. So for those, you can use import time to get the time it is taking. And then you can calculate the time dot time to get the start time and end time. But here we are just to show the partial results, we are using this time. Then you have to set the hyperparameter, that is number of epochs. We are going to use 5 epochs. Then some more variables we are going to create, like training loss, then training accuracy, validation loss, and validation accuracy. So 4 lists will be created for each. Next is to start the training. You have to write a for loop. So for epoch and epochs, I'm printing the epoch number. Currently we are like, let me use epoch plus 1, otherwise it will print 0 first of all. Then we have to call the train function and followed by the validation function. Now a small amount of code is left for training and validation. Please give me some more time so that I can complete this code. Maybe 10 more minutes I need. So as you can see, your train function, this train function will return you 2 variables. Similarly, validation function will return you 2 variables. So when you call train, you have to pass the model. So let me copy the model name. It is CNN model. Then you have to get the data loader name. So it is train underscore loader. Then optimizer name and criterion names. Optimizer is optimizer and criterion is criterion itself. So no more changes are required here. It will return you two variables. One is train epoch wise loss, and one is train epoch is the current epoch's accuracy. Similarly, after completing one epoch in training data, we have to call validation function. So we have validation by epoch loss and validation by epoch accuracy. But it will not need an optimizer here, and here in place of train we have validation function. Then we have to add these losses in this so that we can further plot the graph. So train loss, it is a list, so we can append the data in it. In train loss, we can have train epoch loss. As we are returning, we are returning loss first, then accuracy. So it will give us loss first, then accuracy. So in train loss, we have to append the loss, test train accuracy, validation loss, and validation accuracy. So train accuracy, validation loss, and validation accuracy. Train loss, train accuracy, validation loss. I'm just adding the data in the list so that we can use it after this for loop also. Then we will print the loss values. Training loss and training accuracy.
So it is about to be completed, right? So
yes, ma'am. Validation loss and validation accuracy. And we will print to show it in the form of progress, whether it is training or not. I am using this dash sign, so it will print dash. For 50 times just, and then we will make it print using with the help of time. We will sleep the counter. We are just writing a counter. We'll sleep the counter stuff after 5. The time interval we are using is 5 seconds, and then we will run it. If everything is correct, it will run correctly. I have mistyped epochs. Let's check. Int object is not iterable. So what I have to do, I have to pass this in range. So that's why I have not copied the code in the chat box. So it is saying that I have to write functional maybe. There is the error dot function, that is functional log. It's functional. Now you can see the training is started. Now I'll copy the code in the chat box And till it is running, I'll answer the questions. So up to check up to which part I have pasted the code. Or you can access this from the shared folder. It is available there in the, this is the folder, lab 6 folder. We have created this notebook. And the notebook with the comments are there. The complete tutorial is there already uploaded in lab 5 folder. So I'll copy the code in a single folder. Instead of copying the code in the chat box, can you access it from the shared folder? This ML for CV, day 6, this is the file, transfer learning, sorry, the CNN pytorch. This is the file. Let me answer the questions.
Yeah, it's time to answer the question. We are already 8:04, so I mean, we can answer the question.
So the YouTube link you can access by searching ma'am's name, and then yes, transfer learning is possible. All the models are there available in Torch. The Python
transfer learning is a concept. Concept has to be like PyTorch is only a, you can say it's a tool to write your code. Okay. So transfer learning is a concept. Any concept can be always be, it is always possible.
So another question was that how to visualize the activation maps in case of PyTorch. So again,
yeah.
Library is there you can use, or if time permits, we will explain in upcoming labs.
No, but my suggestion to all the participants here is that we are giving, see, these are very like 40 hours program. In this program, it is not possible to tell you all the things, right? So we have given you an indication as to how to do it. My suggestion is that please explore. There is a lot of material available. There is abundant material available. You can explore from. Now you have been given one hint, like how you can do it in using Carrot. Same thing you can explore in PyTorch. So this is only to give you a quick start, so that you can learn. I mean, you know that there is a possibility. Okay.
Feature map, same question some more participant has asked.
Yes, so it's better that you please explore. That would help you also to learn independently. Thank you.
Ma'am, another question is there, how to attempt tomorrow's quiz? Is there any LMS?
No, we have already shared the Google form link. So
ma'am, many
that link is already shared. Right.
Ma'am, many of them have incorrect registered ID.
No, not registered ID. They have incorrectly written the ID.
Yes,
incorrectly written the ID.
Error is there.
So if there is a typing error, they will not be receiving. No issues. That's there. We cannot help that. Yeah. Yes.
Yes, it is possible to print the feature maps in case of PyTorch, and it's easy, not an issue.
Yeah. So in case your email ID is incorrectly written by you, we cannot help you, my dear participants. You will have to, yes, please.
Ma'am, can we upload the link here tomorrow at 11?
Yeah, we can upload the link. So why you can do it now, even now?
Okay, ma'am. So we will upload the form link here.
Here also. I have already shared in the their email. I have shared to all the participants.
Yes, ma'am.
Right, and then you can also upload here. Ashwin Yadav has a question. Yeah, please. Ashwin Yadav, you please unmute yourself.
Yes. Ma'am, I just wanted to ask Purnima if regarding this optimizer, is there an option for genetic algorithm, or that code has to be constructed exclusively?
You have to write the code.
I think it might not be there as inbuilt function like Adam and others. As was
These are, see, these are optimizers, whereas that genetic algorithm is a method.
yes,
Right.
ma'am.
So it's better that, I mean, we have seen several papers in which GA is used at the end to
Right,
further
ma'am.
optimize the features. Yeah, select the features and finally optimize the output. That
I'm
is where.
talking, yes, ma'am. Ma'am, I wanted to ask from point of view of the solving the loss function optimization when we are training for the weight. So that might be more accurate because we'll get a global solution basically compared to the standard SGD. So that way.
So that's what I'm saying, that some people
Yes,
have
ma'am.
used it.
Right, ma'am.
So you can find out in the literature, but I don't think there are, these are standard optimizers. I don't
Yes,
think
ma'am.
there are standard library functions for GA.
Right, ma'am. Thank you.
Ma'am, it is running and our running code is already shared with them. And the complete code is there. CNN pytorch.
Yeah.
Which has the 10 function again. This is the, up to this part we have reached. Then this is the graph plot we have already explained. And then this is the way you can save the model in pytorch, then load the model. It's torch.save and torch.load. Then to evaluate the model on test dataset, you have to call the validation function, where you have to pass the model name, test data, and criterion. This is the accuracy and loss we've got. And then predict on a new image, you have to first of all create a new transform, because your image is from CV2. You're reading the image from CV2, or you can if you're reading the image with PIL or pillow package, then you can exclude this line. All other lines are same as the actual transforms we have done, because you need PIL image in case of this transforms. The image should be read in the form of from pillow package, not from CV2 package. So that's why we are converting the CV2 image to PIL image. This is the same step, resizing. Either you can do this way or this way. And then we are calling this predict transform, passing the image. It will resize, convert it, and normalize the image. Then you have to add one more dimension to your data. That is the batch that you can do using this unsqueeze. The same way you have done the flatten option, unsqueeze is there in torch. And then with torch.no gradient, pass your data to the model and it will give you one output. Then you can get, using torch.max or torch.topk, you can get the output index. And then you can check from class to IDX, you can check whether the index is correct or not. These are the part we have to cover in the today's lab. So you can see my first epoch is done, second is done, but epoch 3 is running. It will take some more time. So ma'am, can we conclude if?
Yes, that's what I was waiting for. They have got this. So you please run the code.
Both the codes are there in the shared folder, ML for CV. You can access it.
So Ashwin, I just in the chat box, I wrote one article's name, title, Training Back Propagation Neural Networks with Genetic Algorithm for Weather Forecasting. It's very old. This, if you just Google it using Google Scholar, you'll find. Okay, so we can now, I think, call it a day. Purnima, you will be adding the quiz link there, and then we can, I will share with you also the link. Perhaps I have not shared.
Ma'am, one participant has already shared in the chat box.
Acha, ठीक है. Fine. All right, evening, and we'll be meeting tomorrow, not tomorrow, day after tomorrow then, on 28th, when I will be taking a session on object detection, and then Purnima will be helping you with how to make use of YOLO for object detection. Thank you.